My name is Mete Atamel. I'm a developer advocate based in London at Google. And let me just start, okay, 10:30. And today we're going to be talking about containers, Kubernetes, and Google Cloud. So I usually put my slides after my talk on my Twitter. So if you just follow me on Twitter, I already have the slides there, so you can get them from there. All right, anyone recognizes these? Who worked with these before? Yeah, cool. I actually started my software hobby, I should say, with the one here. I had an MS-DOS disk. I would put it on my computer, turn it on, let it load, and after like a minute or two, I would have the A prompt, would take it out, and put another disk. This was GW Basic. Anyone worked on GW Basic or Q Basic? A few, okay. And then I would get into my development environment, and in GW Basic, you had to write line numbers. So I would start with 10, write my command, 20, write my command, and just keep going like that. So all I had was my disk and a book on GW Basic that I borrowed from my friend of mine. And I would that was my Stack Overflow, basically. I would just copy stuff from there to my development environment and try things out. And that's how I learned programming. At some point, I would be stuck for a few days because there was no way to search the internet or anything like that. But I like the simplicity of those times, you know, because I could really focus on the problem that I want to solve. And there was no distractions. There wasn't that much to know about. I had my book, my disk, and that's it. Of course, since then, a lot of stuff happened. By the way, I had animations for all of this, but now with this PDF, my animations are gone, so I'm going to try to compensate for that. But first of all, internet happened, and then after that, we had this all other stuff like, you know, machine learning, cloud computing, IoT, mobile, monolith, microservices, all that kind of stuff. So it's really a much more complicated world that we're living in right now, and we can't know everything. So what I try to do is I try to pick and choose what I like containers and microservices, and learn as much about them as possible, and then try to get an idea on the landscape so that I can speak the language of software to those people as well. But when you want to solve a problem, okay, this was supposed to animate as well, but sorry about this, but we'll start with this. When you want to solve a problem, you first start with your code. So let's imagine that this little piece of red is your piece of code. Your code doesn't live on a disk anymore. It lives on some kind of a machine. So you start with a machine, you deploy your code to a machine, and it's good. But the problem is, what happens when you deploy to a single machine? What happens if that machine goes down, right? So that's not really resilient. So what you usually do is you take the same code and put it on multiple machines. That way you have some kind of redundancy. But then at this point, you have another problem. How do people find the machines? How do they find them? Because each machine has an IP, and how do they keep track of the IPs and stuff like that? So what you do is you create a load balancer that has a stable IP, and then people will get to the load balancer with the IP or DNS or whatever, and it will get to your machines. So this way, there's an easy way for people to get to your services, which is good. But then how do you know that your app is actually healthy, right? Because your machine might be running, but maybe your application is not running. So what you usually do is you create what's called health endpoints, and in these health endpoints, you check what it means for your application to be healthy, and then if your application is healthy, health endpoint will say okay, and that way you have an indication of whether your app is running. Of course, someone has to check this health endpoint, so you usually have a health checker that will check these health endpoints, and if it detects that your app is not running, then it will probably take some kind of action. So it will probably bring down the machine, and then it will like maybe create a new virtual machine with your code and make it join to the cluster again. So this way you have your redundancy, you have your resiliency, and if something goes down, health checker will make sure that things are up and running again, which is good. But then the problem is everything lives on a single zone now, right? And even with big cloud providers, sometimes the whole zone goes down. So if you want your application to be running 24/7, you usually replicate the whole thing into another zone for redundancy. So you do the load balancer and the apps and health checkers and all that kind of stuff in a different zone, just in case this zone goes down. But then at this point, you have another problem. How do you keep track of the state between two different zones? So what you usually do is you create something like a task queue in the middle, where every time you write a state to this zone, you write a message to the task queue, and then someone from here will pick up that message and try to apply the same state to here. And then if your app is really successful, at some point you want to scale out, so you want to add more machines. You can manually add machines yourself, but usually what you want is auto-scaling. You want to scale as demand comes in, and you want to scale down as the demand goes out. So you either use an autoscaler from a cloud provider, or you write your own autoscaler that looks at some kind of metrics and determines if you need to scale up or down, right? So this way, I have everything I want. I have a really resilient, redundant architecture that's spread into different zones, and everything is synced and working, which is great. But if you think about it, this is what solving my problem, this little piece of code, and this is what I have to maintain, right? And this stuff is not optional. Like, you can't just say, oh, I'm just going to write my code and just someone else can figure this out for me. I mean, we used to do that. We used to have, as Edson talked about, like we used to have dev and operations, and I love those days because I could just write my code and just give it to operations guys and say, just deal with it, it's not my problem. But things don't work that way anymore. Like, we are responsible for our code, and we need to make sure that it works end to end. And we need to make sure that we are responsible of the code running in the production as well. But all this stuff is taking time away from the real problems that you are trying to solve. So they kind of feel like it's stuff that you need to do, but it's taking away time from your real problems. So what do we do? If I have to think about software development and how it should be today, I think there are certain things that I want to make sure that it's true. The first thing is I want to be able to write code in any language, and I want to make sure that it runs exactly the same way everywhere. I think in 2017, like, this should be given. You know, we shouldn't have to worry about, you know, whether this code runs on this machine, or whether this code will compile the right way on this machine. Like, all this stuff should go away, and we should have a system where once I deploy my app, then I am 100% sure that it will run exactly the same way everywhere. The second thing is I want my app to be optimally deployed and managed in my infrastructure, but I don't necessarily need to deal with that as an application developer, because as an application developer, I have enough problems to deal with. I have enough problems to solve, so I don't have to worry about this kind of stuff anymore. And the third thing is all resources are provisioned on demand. So when I need resources, I need to have them on demand. And when I don't need them, they should go away, and I should only pay for what I use, right? And if you look at what's happening in technology in the last few years, we are actually getting there. So writing your code and making sure that it runs exactly the same way, that's what containers are all about. So Docker, Rocket, all these container platforms, they are trying to give you a context for your applications to run consistently. Your app is optimally deployed and managed. That's what orchestrators are all about. So Kubernetes, that I'm going to talk about, Docker Swarm, Mesos, they're all trying to do the same thing. They're trying to deploy your code in an optimum way and manage it for you. And finally, all resources are provisioned on demand. That's what, to me, that's what cloud is all about. So Google Cloud, AWS, Azure, they're all trying to give you an environment where resources are automatically provisioned when you need them. So I think we're heading in the right direction. So what I'm going to do in this talk is first, who is using containers in production today? Okay, not many, which is good, because I'm going to talk about containers, why we should even care about containers in the first place. Then I'm going to talk about Kubernetes, so what containers do and what containers don't do, and then we'll look at Kubernetes, why it exists, and then we'll look at the building blocks of Kubernetes and what it can do for your applications. And I also have like a simple application that I show along the way to teach this stuff. Hopefully the videos, if they work here, I'll be able to show them as well. So containers. Why do we even care about containers? We have enough stuff to learn. Like, do we need to now learn containers? And the answer is yes, you need to know containers, because that's how we are deploying software nowadays. And the reason is, when you look at how we used to deploy applications, it kind of looked like this. So you had a single machine, a single operating system, single set of libraries, and then you would deploy your applications on top of that. This was a simple model, one machine, one operating system, one set of libraries. But there was no isolation whatsoever between your applications. So if you change anything with the operating system, or if you change anything with the libraries, you could potentially break everything, right? So that was a simple model, but it didn't really work. Then we had virtual machines. The idea of virtual machines is that on a single machine, you have multiple virtualized operating systems. So you would virtualize the operating system, the libraries, and the application itself into virtual machines. In this case, you have total isolation, which is good. But at the same time, instead of dealing with one operating system, now we are dealing with 4 operating systems and 4 libraries. So it becomes more work to manage these. And these virtual machines, they're not really small. They are gigabytes in size, so you wouldn't really create them until you need them. So what people would usually do is they would write their code normally on their machines, and then when they deploy it, they would create a virtual machine with all this stuff. So it was only used at deployment time. So the containers, they try to combine the best of both worlds. In containers, you have a single machine, a single operating system, but you're virtualizing from your app and its dependencies up. So you put your app and its dependencies into a single container. And these containers are much smaller than virtual machines, so they're really easy to create and deploy. And they're really easy to move around as well, and I'm going to talk about that more. So with containers, you get the isolation that you need, but you also have the lightweight way of creating software. So that way, you have the best of both worlds. So what is a container? It's just a lightweight way of virtualizing applications. They are sealed and isolated, so you can have multiple containers on a single machine. So instead of having 2, 3 virtual machines on a single machine, you can have tens of containers on a single machine. They're very easy to deploy. They're introspectable, so you can actually get into the container and see what's happening as if it's a virtual machine. And for me, the most important part is they're composable. So what you can do is you can, for example, you can have a base image that you depend on. That's your dependency. And you can create your own image, your own software on top of it. And then someone else, if they need your image, they will create their image on top of yours. So this way, all the dependencies are layered and composed, and they're cached as well. So if 2 of your images, they depend on the same base image, if you get the base image once, then you don't have to get it again because you already have it. So Docker is the most popular container management platform, but there are others. There's something called Rocket from CoreOS as well, and I'm sure there will be more going forward. All right, so I think, so the concepts of containers, they've been around for a long time. And at Google, we've been using containers for 12, 13 years. But Docker really made it accessible to everyday software developers. So Docker created this notion of Dockerfile. Dockerfile, it's a file that defines it's basically the blueprint of the container. And it defines your app's dependencies, your environment, and what happens when the container starts. So for example, in this case, we have a dependency to Debian latest, so the latest Debian image. Then we set up our environment with some package installations. We expose some port, and then we define what happens with this command. So in a single command, you define your environment and everything else. And Docker makes sure that this runs exactly the same way wherever the Docker is. All right, so what I want to show you is how to take a simple app and containerize it. So let's hope that our videos work. So I won't show the app first. I will show you the app after we containerize it. So let me see if this works. All right. So here I am in Google Cloud. Let me just pause here for a second. So I'm in Google Cloud Management Console, and there's something called Cloud Shell in Google Cloud. You basically click a button and get a Linux shell, and it connects to a Linux box somewhere in the cloud. And then I created an application called Hello World ASP.NET Core. This is an ASP.NET Core application that runs on Linux. Any .NET developers here? OK, cool. So you guys know what I'm talking about. And for the rest of the people, this is basically the .NET framework that used to run on Windows. Now it runs on Linux. So I like that, and that's why I try to show it in my demos. So I created an app for that. What I want to do right now is I want to create a Docker image out of this. And then later, we're going to use this Docker image from Kubernetes. So to create the Docker image, first what I do is I do .NET publish-c release. This will compile my application and all of its dependencies into a single DLL. So it's basically a single file for my application. In the Java world, this will be a jar file, basically. I do this because I'm going to call this from Docker. So that's why I'm putting everything together. So we'll get that together, and then we'll create a Docker file. So we'll define what our application needs to run. And then once we have the Docker file, we'll build the image, and then we'll run the image, make sure it works. And then we'll push the image to Google Cloud. So the good thing about Docker images is that once you create these images, you can push them to different registries, and you can use them from different places. So that it makes it really portable. So that's what we'll do here. We'll create the Docker image, and then we'll push it to Google Container Registry. It's a special space for your images, and then from there, we'll pull it into a Kubernetes cluster. So I created my DLL, and then I'm gonna, it's here somewhere. I'm gonna just copy my Docker file that I created before. So I'm just copying the Docker file. And then we'll take a look at the Docker file quickly. So I just pause here for a second. So this Docker file, again, the first one is from Microsoft.NET 1.0.1 runtime. So this is a .NET application, and I depend on .NET runtime, and there's an image from Microsoft for that, so I'm depending on that image. So that's my dependency. Then I'm copying some files to app folder in the container. I'm setting up my working directory to app folder in the container. I'm exposing port 8080. Then I'm setting an environment variable called ASP.NET Core URLs. This makes sure that my application starts on port 8080. And then enter point is what happens when the container starts. So I'm just calling .NET and hello world ASP.NET Core DLL. So that's the DLL I created. So with this single file, I define my dependency, my environment, and my runtime, what happens when it runs. So what we'll do is we need to build the image. So we'll use the Docker command line tool to build the image. So Docker is already installed in Cloud Shell. So I'll just say Docker build, and I'm going to tag this with a special tag. GCR.io stands for Google Container Registry. So I'm tagging it that way because I'm going to push this image there. And second one is my project name, and then my image name, and then my version, because I want to version my images. So this will look at the Docker file, and it will step through the steps. So step one is my dependency. I need to get my dependency. So it goes to Docker Hub, and it gets that dependency from there. And then it will go through the other steps as well, and export ports and all that kind of stuff. So I'm just going to fast forward this a little bit, because we are a little bit short on time. So I went through all the steps. And what I'm going to do is I'm going to just run this locally, make sure that it works. So we'll do, first we'll look at the Docker images. So you can see that there are two images. The first one is the one that I just created, and the second one is my dependency image that I downloaded, so they're there. Then I'm going to run it, Docker run. -D means run in the background, so don't hold my console. -P means port mapping, so I'm going to map port 8080 on my machine to port 8080 in the container. So when I go to port 8080 on my machine, it will bind to the port 8080 in the container, and I'll just point to my image. So this way, I'm just running my image. And if you do Docker PS, we should actually see our running image here. Yep, and then if I do a web preview, now this will connect to the Linux box that has this Docker image, and it will connect to the app. So the app is a really simple Hello World app, but we'll use that as a learning thing for Kubernetes. So this is the app. It's running in a container. Great. And the next step is I'm going to deploy this to Kubernetes Cluster, but before that, I want to push this image. So what I'm going to do is first I'm stopping the container, and then I'm going to use gcloud, a command line tool to talk to Google Cloud. So I'll just say gcloud docker push, and then point to my image. So what this will do is it will take the image on my machine, and it will push it to Google Container Registry. And I do this so that I can use this later in Kubernetes. So we'll just point to our image, and at this point, it should start pushing it. Yeah, we won't wait for this, but at the end of this, the image will live in the cloud. All right, how do I get it out of this? All right, now I know how PDF works. All right, so containers are great. They give us a consistent environment, but they are not enough by themselves. For example, if you want to have redundancy, so you want to make sure that you have redundancy in your system, you need to create multiple containers. It's your job to do that. If you want to scale up or down because there's load coming in and leaving, you need to figure it out. If you want to have resiliency, you need to create health endpoints. If you want to roll out a new version of your application, you need to do that yourself one by one. You need to make sure that all your containers are upgraded one by one. And if something goes wrong in the process, you need to roll back to a previous version. You need to do that yourself. Configuration and secrets of your application is very important. We always think of code as our application, but actually configuration is also code in a way. You need to find a way to manage that and get it to your container. So just because you took your application and containerized it doesn't mean that these problems go away. That's why things like Kubernetes exist. So what is Kubernetes? It's basically a container management platform. As I mentioned, at Google, we've been running containers for more than 10 years, and we created something called Borg. Borg it's an internal container management platform at Google. So people who worked on Borg, they learned from it for over 10 years, and then they created Kubernetes as the open source version for everyone else. For me, the greatest benefit of Kubernetes is that it's multi-cloud. That means that you can run it on Google Cloud, AWS, Azure. You can even run it on-prem. You can even have a Kubernetes cluster that spans multiple clouds. So you can have some of your nodes in Azure, some of them in Google Cloud, and you can federate them into a single control panel. It's 100% open source, and it's written in Go. And if you're interested, you can check it out on GitHub. It's one of the most popular projects. At the very high level, this is what the Kubernetes cluster looks like. So there's a master that manages the cluster. and then there are nodes that you schedule containers to. But as a user, you talk to the master. You don't talk to the nodes themselves. And you can use an API or command line or user interface to talk to the master. Now, in this containerized world, a microservice looks a little bit different. So you have your code in a registry somewhere. This can be Docker registry or Google Container Registry. Then from there, you create a template called pod template. So I'm going to talk about what pods are. And then you tell Kubernetes what you want. So in Kubernetes, there's something called Replication Controller. Here we're saying that I want 3 replicas. So you are basically saying I want to run 3 copies of these containers. Replication Controller will look at the nodes that you have available, and it will schedule these pods to wherever it makes sense. So now it's Kubernetes' problem to figure out where to schedule these pods. Once your pods are running, you can label them with different labels. So you can add, like, say, roles and environments, stuff like that. And you can group them into something called service. A service is kind of like a load balancer for your pods. And people from outside will go through the service, and then it will get your pods running on your nodes. So in this world, a microservice is basically a combination of your code with the container and what Kubernetes provides, like replication controller watching your pods and scheduling your pods and service exposing your pods. So it's a combination of your code and Kubernetes building blocks. Here I'll take a segue to container engine. So as I mentioned, Kubernetes runs everywhere. And one of those places is on Google Cloud, and Google Cloud has something called Container Engine. The idea of Container Engine is it's basically Kubernetes as a service. We try to make it really easy for people to get a Kubernetes cluster and schedule containers. Because normally, if you want to set Kubernetes yourself, you need to set up master yourself, you have to set up nodes yourself, you have to set up networking. There's a lot of steps you have to do yourself. With Container Engine, getting a cluster becomes really easy. So to get a cluster, you can just say gcloud container clusters create, and you give your cluster a name. With this, you get a Kubernetes master, and then you get the worker nodes to schedule containers. Then you authenticate your gcloud with Kubernetes cluster, and then you can use kubectl. That's the command line tool to talk to Kubernetes. You can see the number of nodes that you have. You can see the number of pods you have. And you can do even resizes. So you can resize your cluster really easily with just one command. You can change the number of nodes from 3 to 5. So the container engine, in Container Engine, we manage the Kubernetes master. So the Kubernetes master is managed for you. So there's automatic backups, monitoring, there's auto-scaling, there's auto-healing, there's auto-upgrades, all that kind of stuff is done for you. And also, for the nodes themselves, we provide logging and monitoring. So by default, when you deploy a container, when you deploy a container to a Container Engine, you get free logging and monitoring, and you can see them in a central place called Stackdriver. All right, so that was Container Engine. I showed this because I'm going to show my demos in Container Engine, so I just want you to understand what Container Engine is. Now let's talk about what Kubernetes is providing for your apps, actually. And let me check the time quickly. All right. So Kubernetes building blocks. So when you look at Kubernetes, there's like deployments and pods and services and config maps and jobs and daemon sets. There's a lot of stuff, and I didn't even put everything in here. So it can be overwhelming at first. When you first look at it, you're like, wow, that's a lot of stuff to know about, which is true. But at the same time, you don't need to know all of them to start. If you know what a deployment is, what a pod is, and what services are, you're pretty much good to go. And then you can learn the rest as we go along. Now, in this talk, I'm going to talk about some of this stuff. And then depending on the time, I might talk about these or skip them. But I'm going to be around after the talk. So if you have any questions, we can talk about these. 20 minutes. OK, good. And if you can remind me like when it's like, all right, cool, thanks. All right, so deployment is how you start things in Kubernetes. So deployment, when you have a Kubernetes cluster, the first thing you do is you create a deployment and point to an image. And this basically gives you all the lower level things that Kubernetes needs. So when you create a deployment, it creates a pod for your container, then it creates a replica set to watch your container, then it creates a service to expose your container. So it has all the default things. It creates all the default things that you need by default, but everything you would do is from deployment, basically. Initially, you would just create a deployment, and then under the covers, everything is created for you. There's this notion of pods in Kubernetes. So normally, you have a container, and you want to schedule a container by itself. But sometimes you want to group containers. For example, in this case, we have some content somewhere, and there's a container like pulling the content. And it wants to save it to some kind of volume. So that's kind of like the storage for the container. And then you have another container that's serving those files to some consumers. So in this case, you have 2 containers and some storage for your containers. And to you, this is a single unit. What you can do is you can put these into what's called pod in Kubernetes. This way, these containers will live together and they will die together. So Kubernetes will schedule these together. And then, as I mentioned, pod is a volume is pod scope storage. So it's where containers can store state, and they can attach to many different things. So you can attach to persistent disk or AWS or Azure file storage and many others. Once you have your pods, you can label them. So you can say app, my app, or you can say these pods are phase prod or test, or you can say these pods are roll front end or back end. And once you label them, you can select them, you can group them. So you can use selectors. You can say, give me all the pods on my application, or give me all the pods on my application that has the roll front end. And selectors are really important because in Kubernetes, when you create something, like a replica set or service or something like that, you always use selectors to group pods. So that's why they're important. So once your pod is running with some labels, you want to make them available to the outside world. So there's something called service. A service is kind of like a load balancer. You create a service with the selector. So in this case, the selector is type equals FE. And all the pods that have the same label will be serviced by this service, and the service will have the stable virtual IP, and the clients will go through the service to your pods. All right, so let me just show some of this. So I have one that shows how to create cluster, but we'll skip that. So just assume that we have a cluster. Let me show you the one with the deployment. So in here, I already have a cluster running that I created before that I didn't show you, but just trust me that it's there. What we're going to do is we're going to use kubectl to create a deployment. But before I can do that, I need to authenticate with this cluster. So I'm just going to copy a code that Google Cloud gives me to authenticate. And with this, now I'm authenticated with Kubernetes Cluster. And now I can run kubectl command. So I'll just say kubectl run hello.net. This is the name of my deployment that I'm giving. And then I'm just going to point to an image. So this image is the image that we created and we pushed earlier to Google Cloud. And since it's in Google Container Registry already, I can just point to it like this. So I'm just pointing to my image that already exists in my project. And that's it, really. And I think we need to specify the port as well. Make sure the port 8080 is available, because that's what we need. And with this, like within a second or two, we create a deployment. So if we do kubectl get deployment, we'll see that our deployment is already there. And then if we do, like as I mentioned, deployment creates other things. So it creates pods. So if you look at pods, there's already a pod that's being created. It says container creating. But if we do get pods again, we should see that the pod is running. So within a couple of seconds, it schedules the container and it runs. And if you do get replica set, I'm going to talk about what the replica set is. There's already a replica set created for me. And then if we do kubectl get services, we'll see that there's a service that's been created with an internal IP, but it doesn't have external IP yet, because we haven't exposed it to the outside world. So all the defaults are there. And then in the next one, let's just create a service for this so other people can use it. So to create a service, first I want to make sure that my deployment is running, so it's there, and then I want to see that my pod is running as well. So that's also running, that's good. So to expose this to the outside world, I'll just say kubectl expose deployment, and then pass in my deployment ID. And then I'm going to specify the type of the service I want. So in this case, type equals load balancer. So what this means is that create a load balancer in Google Cloud and attach this to Kubernetes Cluster. And that way, when people hit the load balancer, they will go to the service, and then from there, they'll get to the pods. So if you do kubectl get service, we will see that external IP is pending, because the load balancer is being created. This usually takes like a minute or two. But once we have the external IP, we'll have our pod running. So I'm just going to fast forward here, in the interest of time. So I think at this point, we should have a service, hopefully. Yeah. So in here, we have an external IP. That means the load balancer is up and running. So if we hit that endpoint, we'll see the same app running. Now, the difference is, this app is not running on a Linux box somewhere by itself. It's running within a Docker container that's being managed by Kubernetes, and it's being watched by a replica set, and it's been exposed by a service. So it's being basically fully managed by Kubernetes at this point. So it's the same app, except it's managed by Kubernetes. All right. All right, so up until this point, there's nothing special actually. Like we just created a container and we just deployed it to the cloud. But you might ask, like, what's so special about Kubernetes? I mean, I can do that as well, right? And you're right. But I think what's special about Kubernetes is that once you let it manage your containers, you get a lot of things for free, and it makes your applications more resilient and redundant. So let's just go through those now. First, you get this wonderful thing called Replica Set. So Replica Set is kind of like a big brother watching your container and making sure that your container is always running. In this case, for example, we have a Replica Set that has a selector, so it's managing these pods with these labels. And then we are saying that we want 4 replicas. And Replica Set will basically will keep asking Kubernetes API server how many pods I have. And if at some point it detects that you have 3 pods, it will create a new one. If it's 4 pods, then it won't do anything. But it will constantly watch those pods and make sure that they are running. So for example, if you have 2 pods and A and B, initially Replica Set will look at them and say, okay, I have 2 nodes to schedule things, so I will schedule this one here, this one here. But then if something goes wrong with node 2 and it goes away, because maybe the machine went down or something like that, then it will immediately detect that and it will reschedule pod B to the single node that we have. So that way you don't have to worry about this, you know that someone is watching your pod. Scaling becomes really easy with Replica Set. So let's say you have 3 pods running under the Replica Set. You want to go to 4 pods. You can just run one command, and with one command, it will schedule a pod, and you will scale out. If you don't want to do manual scaling, you can do auto scaling. So you can install something called Hipster that will collect some CPU metrics from your pods, and then you can set a rule in the Replica Set and say, I want to scale if the average CPU target is more than 50%. If this reports that, then Replica Set will add more pods until the average goes down. And also, so this is pod auto-scaling, but also in Google Cloud, there's something called node auto-scaling. So the actual machines where the pods are scheduled, that can be auto-scaled as well. So that way you have 2 levels of auto-scaling. The nodes auto-scale and the pods auto-scale, and you don't have to worry about anything. Things just are elastic like that. You want to do Canary deployments. For example, let's say you have a version 1 of your application running, and you want to introduce a second version. What you can do is you can create a new Replica Set and add a pod to it. And the same pod can be serviced by the same service, because this service looks at this selector, type equals BE, right? So all the pods, they have type equals BE. But under the covers, some pods run version 1, and some pods run version 2. So this way you can introduce new versions to your deployment and test it out and make sure that it works. So that's Canary deployment. It's really easy with Kubernetes. And you can do rolling updates. So for example, let's say you have a version 1 of your application running, and it's being serviced by the service, and you want to do an update to version 2. What Kubernetes can do is that you basically go to your deployment and change your image from version 1 image to version 2 image, and then hit save. Once you save that, this is what happens. First, Kubernetes will create a new Replica Set with version 2. It will add a pod to it, and this pod will be serviced by the same service, so it basically creates a Canary deployment. And if everything is good, it will take one out here, then it will add one there, then it will take one out there, and you just keep going like this. And then at this point, all the pods are version 2, and we don't need this anymore, so it will take that out as well. So this rolling update happens automatically. All you have to do is just go to the deployment and change the version from 1 to 2, and this happens for you for free. All right, how much time I have? 10, 11, okay, good. So I can show some of this as well. So let's look at the replication. So here I have a pod running. Let's say, and this is the pod ID. Let's try to kill this pod and see what happens. So I do kubectl delete and pass in the pod ID. And now Replica Set will basically say, oh, this pod is being killed. I need to do something about it. It's going to kind of freak out. And it's deleted. And if you do get pods again, you see that there's a new pod with a new ID, and it says status container creating. Because Replica Set right away detected that the pod is gone, and it created a new pod already. So that's how fast Replica Set acts. So that's the replication. If you want to scale, so you want to scale up or down, this is how you do it. So you can do kubectl get pods. You have 1 pod running. Let's say you want 2 pods. So for that, you just say kubectl scale and pass in your deployment ID, and then just specify how many replicas you want. So it will be replicas equals 2. And now, with that, if you do get pods again, within like a second or two, you have 2 pods running. So that's how you scale out. If you want 3, same thing, just change 2 to 3. In this case, if you do get pods, the third one will have pending state because we only have 1 node, so we don't have enough resources, but it will try to do that. And if you want to scale down, you just say replicas 1, and now you scale down from 3 to 1. So scaling becomes just one command, as long as you have enough nodes to scale, obviously. And then to do the rolling update, so to do a rolling update, what you need to do is first, you need to change your code. Then from that, you need to create a new DLL. Then from that, you need to create a new image and push that image. And then you can use it in Kubernetes. So that's what I'm doing here. I'm not going to show you the whole thing, but what I'm doing is I'm just changing this message that says learn how to build ASP.NET apps that can run anywhere to Google Cloud. So I changed that, and now I'm going to go through like creating a new DLL and so publishing it and then creating a new image, all that kind of stuff. Let's just go fast forward here because that's not the important part. So I created the image, and then I am doing Docker push. So now I'm pushing the image to Google Cloud so I can use it. And then after that, I want to do a rolling update. So to do that, I'll say kubectl edit deployment. And then I'll just pass in my deployment ID. So this will give me the YAML configuration for my deployment that I created before. And all I need to do is, under here, there will be an image section where it tells us which image this deployment is using. Right now, this is pointing to version 1 of my image. I'm going to change this to version 2, to my new image. And when I hit save, it will do a rolling update that I show you. So all this stuff by one updating, it will happen automatically. So now, if you do kubectl get service, and we go to the IP address, we should see our deployment already updated. So if you look at the text here, it should say run on Google Cloud. So it already happened anyway. And this rolling update and the how fast it updates pods one by one, you can configure that as well. All right, and then there's more stuff. I just want to mention these like in one sentences each so you know what they are. So your pods are running, but how do you know that they're healthy? So there's something called Readiness Probes. You can specify an endpoint and a port, and you can give some configuration to Kubernetes. With these, Kubernetes will ping this endpoint and port, and it will make sure that your pod is running. If not, if it gets not OK, then it will kill your pod and create a new one. So this way you can tell Kubernetes if your pod is healthy or not. Sometimes your pod is healthy, but it's not ready to serve traffic yet because maybe it needs to get some kind of state from some kind of database or something like that. For that, there's something called liveliness. Oh, sorry. The liveliness probe was the one that I talked about, and then the readiness probe is basically when it's ready to serve traffic. So Kubernetes will hit this endpoint, and it will determine whether it should direct traffic to this pod or not. There's a dashboard. By default. So by default, you can see your deployments, your services, your replicas, that's everything. And you can see pods, CPU usage, stuff like that. Okay. And then you can have daemon sets. So pods, they can live on any node. There's no guarantee where they live. Kubernetes figures out where they live. If you want to make sure that a pod lives on every single node, because maybe you need to collect some metrics from every single node, you can create what's called a Daemon Set. This way you make sure that every pod lives on every node. Pods live forever, and if you kill them, the replica set will determine that and will create a new pod. But sometimes you don't want them to live forever. You want them to be created for some work, and then when the work is done, you want them to go away. So that's what jobs are for. You can create what's called jobs, and they will look at some kind of metric that you define, and it will create pods for that to do the work. And then when the job is done, the pods will go away, so you don't have to pay for them. There's stateful sets. So pods are stateless. There's no state in pods. But sometimes you want to have a state because you want to run applications like these where you need to have a state. And sometimes you want to also be able to configure the order of the pods. You want to be able to say, I want this pod A to start before pod B, things like that. For those kind of use cases, there's stateful sets, so you can define the state and the order of the pods. And then lastly, configuration. So in Kubernetes, there's config map. It's a central place to define configuration. So it's key value pairs that you can define. And when your pods start, they will get a volume with the configuration. This way, there's a central place for the configuration, but then every pod will get the configuration as they start up. And then finally, secrets. So same thing as configuration, but you can define more sensitive information like passwords and secrets. You define in a central place, and then they get attached as a volume. All right, that's all I had. Thanks very much. If you want more information, kubernetes.io is the link. If you want the links, this is my Twitter. And I'm going to be around a little bit after my talk, so if you want to ask questions. Do we have time for questions right now? Yeah, we do? OK.
Any questions for Mete? Don't be shy.
Hello, hello, hello.
How is Google working with GitHub repositories for definitions of Kubernetes?
How Google is working with GitHub, you said?
Yes.
Yeah, I mean, Kubernetes is on GitHub, and it's open source, and then there are Google engineers contributing to that directly on GitHub. Yep.
Anybody else? We still have time for a question. Come on. Last call. OK. Thank you, Mete.
Thank you.